Today we're going to be talking about plane curves and parametric equations. And this first lesson is kind of an introductory reminder of what parametric equations are. So there are times when we need to describe motion or a curve that is not a function. So you see right here, we have something that is a curve that is not a function. We do this by writing equations in x and y, and then the independent or the independent variable, I said that correctly, was usually t or theta. So you have an equation where you get your x coordinate in terms of t and your y coordinate in terms of t. And these are called parametric equations, and t is the independent variable. Hopefully I said that right earlier. So sketch and identify the curve defined by the parametric functions. So getting some points, I always start with t equals 0. What do I have here? 1, 2, 3, 4. A lot of times I believe they're going to say t is greater than 0. So when I get these points, I plug in 0 and I get a 1 for y. So I plot that point. You know what? I'm going to get all of my points so that I know what to make my scale. So it looks like my y scale goes up to 5. My x scale goes all the way to 8. I have some negatives in there. Okay, so I have the point 0, 1. So that's kind of like my initial point. And then I have negative 1, 2. And then we have a 0, 3. And we have a 3, 4. And an 8, 5. So hopefully you see that the curve curves that way. And typically we put arrows on the curve, just kind of telling us which direction we are going. Remind me during class, I'll show you guys how to confirm this on your calculator. I'll show you guys how to graph parametrics on your calculator. I just don't want to bring it up right now, trying to make a shorter video. So what does that curve kind of look like? It kind of looks like a quadratic. And eventually we are going to convert these expressions so that I can confirm that it is a quadratic. So I'm going to convert it into rectangular coordinates, so x's and y's. Okay, and there's a good example of how I'm going to convert in terms of x's and y's. Okay, what curve is represented by these functions? Okay, I'm going to divide the first equation by 3. So I get x over 3 is equal to the cosine of t. I'm going to divide this by 4. So I get y over 4 is equal to the sine of t. And then what I'm going to do is I'm going to square both sides. I had my parentheses in there because I was already looking at my notes. So I have here x squared over 9 is equal to the cosine squared of t. We know we have y squared over 16 is equal to the sine squared of t. I'm going to add the left sides together. I'm going to add the right sides together. And adding the left sides, adding the right sides, I get 1 is equal to the cosine squared of t. Oh, I did that the wrong way. Cosine squared plus sine squared is 1. So we get x squared over 9 plus y squared over 16 is equal to 1. And hopefully you recognize that this is an ellipse. Okay, sketch a curve represented by the equations below by eliminating the parameter and adjusting the domain of the resulting rectangular equation. Okay, so t is greater than 0. So just adjusting our domain, if t is greater than 0, I'm only plugging in positives here. My x's are going to be greater than 0. Okay, so what I'm going to do is I need to solve one of these equations for t and plug into the other one. I'm going to multiply both sides. I'm going to multiply by, I'm going to flip this. So I'm going to make this root t is equal to 1 over x. Basically, I just cross multiplied. Okay. And divided by the x. I now square both sides. I now have something for t that I'm going to plug into that equation. Okay, so now looking at this, we know an x to the fourth, well, x to the fourth kind of looks like an x squared, and x squared, remember, is a radical function that looks something like that. And as I plug in more and more x's, it's going to go this way, I believe. So it starts here and goes up this way. Yes, because the x's keep getting smaller and smaller and smaller, and the y's keep getting bigger and bigger and bigger. Okay, example 4. Given the set of parametric equations that represents, find a set of parametric equations that represents the graph by using the following parameter. Okay, I don't know why I was confused by this. Okay, so I need to now write this. I'm now going the other way. I'm writing this as a parametric. I kind of already have one. So this one, if I add the x over and I subtract the t, I have one parametric. Now I know that x equals this, so if I substitute in here for x, I'm going to get y equals 4 times 2 minus t minus 3. I get 5 minus 4t, so now I have a y equation and an x equation, and that's what I needed. Okay, so that's your introduction to parametric equations. Hopefully you remembered a lot of that stuff from your previous math classes, but that was a few years ago, so you may not have. So hopefully that was a good review for you.